Thank you very much for inviting me to the meeting at Cal State San Bernardino. I'm very sorry I cannot be there in person, but I really appreciate the invitation from Gerard to participate and for letting me present to you via video. So my name is Eva Dielman. I'm a research professor in the computer science department at the University of Southern California, and I'm a research director at the Information Sciences Institute, also at USC. So in my talk, I would like to describe the workflow management system Pegasus and how it allows you to go from scripts to workflows that can be run efficiently across a variety of cyber infrastructure. So typically when somebody wants to compose an application that has several parts, they use scripts because they're quick to code and deploy. You can quickly write something in less than an hour. They're quick to learn and to tailor to the local campus resource, so to generate the submit scripts. But they're not very scalable. They're hard to move between resources. So one script won't work on a resource in San Bernardino or at UCR. They're hard to maintain because things as systems change over time, you need to change your script. And they're also hard for others to understand. They're often or error prone as well. It's easy to make a mistake that makes the whole script fail. So a solution to that is to express the computations as multi-step workflows. And the Pegasus workflow management system allows you to do that in a declarative way. It supports automation, which also minimizes human involvement. So we typically have fewer errors. It makes the analysis easier to run. The description in Pegasus is portable across execution platforms. So you describe the workflow in a resource independent way. You talk about doing an FFT on file A, which then gets translated by Pegasus to a campus cluster, to an HPC resource, a cloud, or the edge. It helps you keep track of provenance and supports reproducibility. It makes workflows easier to maintain because you can swap out components easier. It fosters collaboration because you can share the workflow with others, even though they're outside of your institution. They can tailor it to their systems. But on the other hand, it takes some time to learn about these new technologies. So what our workflows can be very simple. They can just be bags of tasks that you see on top. And so this, at the bottom, you see an example of an astronomy workflow that just takes information about light curves and then generates a variety of data products from that. And you can also take these very, very simple computations. You see a student here from the Colorado School of Mine taking a two-step workflow that does, actually three-step workflow that does a Monte Carlo simulation. And he was able to scale these workflows, multiplying basically running the workflow of different parameters to almost 600,000 tasks, which if you run it sequentially would take 15 years to complete. But he did it in 4 hours on the Open Science Grid, which is a HT Condor deployment that's available to researchers in the US. So in this case, Pegasus provided automation and scaling, automatic job retries on failure. It moved the data to the computations and out of the computation. It also managed the disk space at the execution sites. So Pegasus addresses a number of challenges that users have running computations at scale or even across various clusters. So it does automatic data transfers to and out of computations. It can talk to a variety of different storage systems using protocols such as HTTP, FTP, Globus Online, HT Condor, and can talk to cloud resources as well via S3 and other types of protocols. If the workflows are designed with very short running tasks, which are typically not efficient to run, Pegasus can cluster them together for efficiency. If you're running on an edge device, it can also analyze the workflow, clean up storage as it goes along, so it can fit in the workflow. If there are failures during the execution, it has a number of mechanisms such as job retry, trying different data sources. It has workflow checkpointing, so you can restart computations from where you left off, and also produces the leftover workflow if it cannot resolve issues. Now, Pegasus can also reuse the data, so you can, that's already been computed, so even on failure, you can give a workflow again, and Pegasus will only run the jobs that are necessary to run and will use the data products. If you don't know what happened during the execution, we have tools for analyzing workflow performance, help debug workflows, and pinpoint the errors. All the while, Pegasus keeps track of how the results are obtained, so it provides full provenance records, and it also supports characterization for reproducibility. How do the workflows start? Typically, users draw workflows, and then they map these workflows using the APIs that we provide in Python, Java, R, and sometimes also within Jupyter Notebooks. So designing these workflows and then submitting them to Pegasus for planning and execution. If you want to try the software, we have the software available on Access. Access is an NSF-funded set of resources and services that includes high-performance computing systems, clouds, HN Condor, and other resources that allow you to do various types of computations depending on your science needs. You can get an Access account with your institutional credentials. You just need to wait for an account to be authorized. And then you can, typically you would get an allocation to do production work, but you can also use our test pool to just try Pegasus without needing to get an allocation. So when you log on, you get an account, and you go to the pegasus.access-ci.org. You can open up a Jupyter Notebook within an open on-demand instance, and from there you can run our tutorials and learn about various aspects of Pegasus and run them again on this test pool. From there, you can also graduate from the test pool, get an allocation, and run more complex workflows or the workflows that you want to design. So this is a page for the notebooks where you can learn. We have different tutorials starting from the first one, which is a very simple one, to various types of additional complexities. And then you can also see we have different types of example applications you can try or start with. If you need help, we're here to help you get started. So please engage with us. We have a Slack channel. We have an email for support. We have office hours every Friday, the first Friday of every month. We have tutorial walkthroughs, but otherwise come as well and get your answers. You can email us at pegasus@isi.edu as well, and go to our website where we have all the information. So again, thank you so much for letting me participate via video recording today, and I hope to meet you in person at some other opportunity. Thank you.